Let's put the unit circle into practice, answering a few basic questions. Problem 1. What coordinate on the unit circle corresponds to the cosine value? Well, that is going to be the x value. So x is always going to be for cosine, y will be for sine. So if I want the cosine of pi over 3, I'll come to the angle of pi over 3 and choose the x value. 1/2. What coordinate on the unit circle corresponds to the sine value? That's going to be y. So for the sine of 3 pi over 2, I'll come on down to 3 pi over 2 and choose the y value. I get -1. The reciprocal of secant is going to be cosine. So the secant of pi over 6 should be equal to 1 over cosine of pi over 6, which means I'll again go to look at the x value, but this time of pi over 6, and get square root of 3 over 2. So I'm looking at the reciprocal of root 3 over 2, which is 2 over root 3, and that rationalizes to 2 root 3 over 3. Problem 4. What identity relates tangent with sine and cosine? Be the identity tangent theta is equal to sine theta over cosine theta. So if I want the tangent of 11 pi over 6, that means I want sine of 11 pi over 6 divided by cosine of 11 pi over 6. So I'll need both the x and the y values from 11 pi over 6, giving me -1/2 over positive root 3 over 2, which simplifies to the square root of 3 over 3. Problem 5, is sine even or odd? Well, from the chart above, we know that sine is an odd function, meaning that sine of -5 pi over 4 is equal to negative sine of positive 5 pi over 4. So again, we'll go grab the y value, but for 5 pi over 4, that y value is negative root 2 over 2. So we're looking at negative root 2 over 2, which simplifies to positive root 2 over 2. Problem 6, is cosine even or odd? You know that cosine is an even function. So the cosine of -5 pi over 3 is just equal to positive cosine of 5 pi over 3. So we'll go grab the x value at 5 pi over 3 and get 1/2. Problem 7. Finding a smaller positive coterminal angle for 15 pi over 4. Recall that to find a coterminal angle, we always want to either add or subtract 2 pi. In this case, we're going to need to subtract 2 pi in the form of 8 pi over 4 to get 7 pi over 4. And then the next part, the reciprocal of cosecant, we know is sine. So if we're looking to get the cosecant of 15 pi over 4, we are going to find that by taking 1 over the sine of 7 pi over 4. Going to the unit circle, I want the y value at 7 pi over 4, which is negative root 2 over 2. So this is 1 over negative root 2 over 2, which is negative 2 over root 2. And that simplifies to the negative square root of 2. Problem 8, finding a positive coterminal angle of negative 19 pi over 6. Here's where we'd want to add 2 pi, but adding 2 pi won't be quite enough. So instead we're going to add 4 pi to add 2 full circles to come around to a number that is positive. So I'm going to want to add 24 pi over 6, giving me 5 pi over 6. Then we want an identity that relates cotangent with sine and cosine. That should be cotangent of theta is equal to cosine over sine. So again, we're going to need both the x and y values at 5 pi over 6, which is up in the second quadrant. So the cotangent of negative 19 pi over 6 is going to be equal to the cosine of 5 pi over 6 divided by the sine of 5 pi over 6. Which means that we want negative root 3 over 2 divided by 1/2. And that simplifies to negative square root of 3. Then let's cover some highlights of problems 9 through 20. In problem 9, we're looking at the tangent of pi over 2. And tangent is the y value divided by the x value, which in this case would result in us dividing by 0, which means that we're not going to get a solution. So that's going to be undefined. In problem 11, I want to find a coterminal angle to negative 5 pi over 6, which I found was 7 pi over 6. 7 pi over 6 is in the third quadrant where tangent is positive, and it's a pi over 6 angle, so I know I should have 2 3's in my answer. So that must be positive root 3 over 3. Now for 13, cotangent of 3 pi, I first found a coterminal angle, which was pi, and cotangent is undefined at pi. In 14, I found a coterminal angle to 11 pi over 4 and got 3 pi over 4. 15, coterminal angle to 11 pi over 2 was 3 pi over 2. In 17, a coterminal angle to negative 11 pi over 6 is pi over 6. A coterminal angle to negative 4 pi over 3 is 2 pi over 3. In problem 19, I used the fact that secant is even to say that secant of negative pi over 3 is equal to positive secant of pi over 3. And in problem 20, I found a coterminal angle to negative 23 pi over 6 to be pi over 6. Keep in mind that you will need to add 2 pi twice in order to make it to pi over 6.